Hello, everyone. Thanks for joining Programmers Week. For those who don't know me, I'm Deepak Kaushik. I'm a senior data integration lead at Cognizant Softvision. And right now I'm mainly focusing on integration of data and system from external into the enterprise ecosystem so that that data can be utilized for various purposes. I'm working with the Cognizant Softvision close to 5 months, and I'm very excited about these talks on real-time event-driven microservices and how that is shaping the needs of future analytics reporting, AI, and machine learnings. I would encourage everyone to ask questions in the chat module, and we'll try to answer as we progress. And without wasting your time, let me just get started with my presentations. So in today's presentation, we are going to talk about three core agendas. We'll start with our understanding on real-time, event-driven, and microservices. We'll see some of the example, how and where those scenarios are used and how the industries are taking the best practices into their day-to-day implementation. And then we'll dive into our second agenda item. We'll talk about more specific about the very high level architecture design pattern and one of the technical platform, Kafka, how we are utilizing the event driven and how that is supporting for data in feed into your organizations. And finally, we'll talk about how the real-time event driven is going to help in the overall data streaming for the analytics, AI, and machine learnings into the organizations. So let's start with our first agenda item on real-time event driven. So let's start with the one of the very common use case from the logistic organizations, and most of us, we came across this on quite frequently, whether we are going to book a package for our near dear or we are just buying it from any e-commerce website. So first of all, everybody want the time of delivery, right? When I'm going to get my iPhone 13, right? It's just recently launched, right? I'm just eagerly waiting for everyone, right? So that you're going to order online, you're getting the order, and then that is shipped from Apple or any store that you bought it. So you just anxiously waiting for that particular delivery, right? So there are various phases of that package, being loaded on the delivery van on the flight, or is cross country, right? Cross continent, right? So it's very important if each transaction of your package that is being delivered to you, right, in some time, right? How do you get exact time of delivery? And also for the delivery guy, right? He don't want to get it into a kind of a delivery reattempt, right? The first time he happened to make a delivery, he makes his next delivery, all the delivery on time. And second one is the route planning and optimization, right? You let assume that the delivery van has all the onboarded packages, right? What need to be delivered for a particular day or part of his shift. Once it's delivered, is ready to go, the most optimal route plan based upon all the packages that are scanned, right? The system can give you, and then you can perform the timely manner on the priority of the packages that are onboarded and what can be delivered first, what can be delivered a later point of time. Also, as we live in different time zones or different conditions of weather during snow or rain, or there are some accident or blocking, right? The real-time events will help you take the alternate route and keep your delivery commitment intact. And finally, right, you are having a lot of package to deliver, you can plan your resources based upon a given day or time, what is the load that you have it, and you can optimally plan the resources accordingly. Just moving on, just one more example. Car ride, we all know, I've taken a ride in Uber or a Lyft some point of time. That's a perfect example of how events have been driven. Somebody's want to know, I'm just there in a downtown, wanted to look what are the rides available for me nearby, and a driver just around the corner, he's also looking for the next pickup, right? How these two are very much connected in more real time of how much far the car is available and how much time it's going to take to pick up the ride, and also the user get to know, oh, he's getting in next 2 minutes or 3 minutes, or he can have any alternate. And definitely coming back to the again, like we talked about more logistic use case, different weather conditions or different can prompt real-time alerts to take decisions and take reroute, or based upon the real-time informations can take more decisions. And also once you have end of your trip, it's getting paid, user get all this invoice receipt, and driver get his share of services what is offered, right? So this all thing is happening on more real time, right? It's all you're onboarding a cab, you're just going through your ride and just dropping to the airport, and you're going for the next ride. Now let's talk a little bit about we know we are in age of, right, APIs, right? Every tool and every product, right, has their APIs, right? So if we compare, right, real time versus the request and traditional request and response phenomena. So there are use cases for each, right? It's not that we can solve all the problem with our web APIs, right? And we can solve all the problem with event-driven approach, right? There are set use cases and solutions that we can do for each scenarios. So there is not one fit solution for all. You need to see case by case and how that can solve that particular problem. So for our case, let's compare the real-time event versus request and response. And let's pick the same example where, a user is waiting for a car to get right? In traditional request response is saying, okay, my car is ready, and okay, if that system is more based on that, say no, it just keep on asking till it says ready, right? So in that particular way, if we just put it into context of just an APIs, right? So they are, request and response back and forth from the server and user. Yeah, it's not a very good user experience because there are a lot of noise. And if we see the workload, right, if the scalability of the solutions is considered, right, the more number of users getting into your platform, right, making it more and more noisier, and might have problem in sustainability in future long run. But just like this particular use case into eyes of real-time event, right? So the kind of the interaction is going to definitely change, right? First is you just say, okay, tell me when I'm ready. The car says, okay, and car says ready. That's here it comes, right? So it's a whole together change of approach and solutions when we think in terms of events, because user just he just kind of wanted to know when the car is ready for me to ride, right? He doesn't bother about if car is different cars are saying no, no, no. He just want book on a platform, and then one car is there for the service, right? So if we just compare with the same one, definitely that use case seems much more kind of recommended for real-time events because it's just handling what basically the real-time event means, right? Getting the information to the user or system who need it, right? And when they need it, which is very, very important, right? When the time factor, right? It's not that I need something and it's delivered to me by end of the day, right? I need it now. And if it is delivered to me now, that is going to make me happy, or that is going to make my business to run efficiently. And that is going to make kind of a differentiator in the whole market for my business or my process or my services that I'm offering to a larger platform. So that's where the real-time event kind of approach we can have, what kind of use cases, right? We have to figure out the use cases where it can fit and how it's going to benefit the overall solutions here. Okay, just a kind of a segue. So we talked about real-time and event-driven. Just wanted to talk a little more in depth about how we see with respect to, traditional world of monolithic and how it came a long way to the microservices and coupled with event-driven microservices. So we all know, right? More monolithic server, monolithic applications. We have one big application doing all kind of business rules, business implementation, user interface, and just taking the same example, extending it from mobile user want to have a car ride, everything into one application, right? So yeah, it's doing its job, but there are some drawbacks about the scalability, if the availability of any of the components there, the whole application, whole stack of users, the services are hampered, which is definitely not good for any kind of a solutions, right? And then we that came along somewhere in a kind of a service-oriented architecture, where the monolithic architecture kind of split into different service, which sometimes can still have the shared infrastructure. For example, let's say database. So it's kind of doing somewhat better in terms of managing the user experience on one service and or the car or the infrastructure on a different service, right? But still, they had the moment of truth, sharing the same info, right? If there is a load on from the users or load from the car transportation, right, increase, that definitely do impact crisscross one or the another. So that has its advantage, but comes with some drawbacks. Now we came into the era of microservices. Each one is developed separately, has its own isolations of transactions, and they are quite atomic in the sense of what a request and a response, which they can give to their consumers. And then in meantime, they if they need to talk, right, they are talking through APIs or different interfaces. So that's where the microservices going to fit, giving some advantage on the scalability, availability, and managing a lot of challenges with respect to the system overall scalability. I'm not saying microservice is all better than monolithic. Yeah, that's always debatable. There are some advantage of monolithic with respect to microservice and vice versa. But going as we getting into more world of focusing on more functional business scenarios, microservice is getting more attractions. Now with this microservices, right, they still, if you look at that way, right, user and car service, right, they still talk to each other, right? User service is kind of, if car service is not available, right, that definitely hamper some of these availability with respect to the user services, right? We can handle with a lot of load balancing and other scenarios. What I'm trying to get a point is, there is to this microservice solutions. What if we have the similar microservice solutions, and let's say all the car, right, like car driver, right, it keep on sending all the locations and how much time and distance, it's from the users, keep on sending to user services through kind of a data stream, and user services just subscribe to all those events they are getting it. So this way they are completely decoupled. They are not depending upon the availability of car service all the time. If they have events, they can consume it. And similarly, the car service can get all the, if user had booked that particular car that is available on the roads, so they can book it. So it's kind of coupling the microservices with an extension of event driven, which these microservices are publishing their events to a stream which the other services can subscribe to, and based upon that they can function all their business logic, or they can still service the consumer for the request they are getting it, and then they can scale based upon what kind of load or availability zones they are looking forward. So this way we are talking about how from monolithic architecture we are evolved from different phases, bringing into different microservices, and also getting the picture of how we can bring in the event stream into the process of making these services more and more resilient in terms of their availability is concerned. Okay, so we talked about real-time event-driven, right? Now, yeah. So how do we do it, right? That's the next question that we have, it, right? So we have event-driven architecture pattern, right? Any particular given problem, right, we can solve through various approaches, right? And so we have a lot of design patterns which are defined, kind of, I would say, the proven, have implemented at scale, different enterprise, different systems. So we can have a look at those design patterns, especially for how to make the system more event driven. So we can have, there are a lot of design patterns, right? For each business use case or scenarios, we can use one kind of a design pattern, but we can use a combination of design pattern. It's not mandatory that a particular problem can only solve by one, but there is always drawbacks and the positive for each design partner, and that we might have to see what fit the particular problem statement. So we are going to discuss quite a few of them, not to discuss everything, considering with respect to the time we have. So the most, I think, for event-driven, right, it's been used quite widely, is the event sourcing design pattern, which is kind of the name itself, it's kind of storage of all the events. It keeps track of any event that is happening or changing the state of that particular entity. And it's kind of has its atomicity, because each event are being recorded. And in case any application or platform, right, want to recreate that entity, right, since it has all the events in the store, right? They can reconstruct it. Let's take an example. We have an order service, which is primarily responsible for any events that happen while creating an order or while going through the overall process of approving the order. Or the order is been shipped for the customer that ordered it, and also customer service is also one kind of interested, as and when each event is triggered, they want to have the stakeholders keep informed. So here, order services, it keep adding and appending all the events into the event store, and customer service, since they are interested into these events, right, they can always listen to this particular or any particular event. So there, the event store keep the track of all the atomic event that has happened. So that's where mostly the use cases, where uh, the application, right, in case, right, need to recreate any particular entity or object is required, where the final state, along with the final state, the changes that happen right along the state is also important. So now let's talk about a little about Saga Design Partner, which is also called as database per service, which is kind of a concept where each service has its own database. So any event that is there in the boundary of that particular service make transaction to the database, and once the transaction is completed, it goes into a send an event to another service, which does the same for the scope of the operations for that particular service. For example, we see, right, we again take example of order services. We have order placed, order created, and then once each event is done, it is sending event to the customer services to send maybe the confirmation to the customer, okay, the order is approved, and so date you will have the order shipped, and what is estimated time that you can have the order delivered to you. So one important aspect of Saga is also, since it is like kind of how you manage the if a transaction is distributed across different services. So that kind of use case fit very well with Saga, because it's also provide how if for example, if customer place an order and moment or a day earlier, say it doesn't need it just cancel the order, right? So that it provide a flexibility in compensating back, what are the changes that have been made into those processes or services. So in respect to Saga, there are kind of there are two type of implementation that can be done. One is choreography, where different services interact each other. There is no central unit. Once the job is done, they will send the events to another one, and the whole transaction is completed. And the second one is more an orchestration based, where there is a central orchestration which takes control of which services need to be in line next to perform which task. For example, if there is order creations and payment, right? So the order is created, it goes and send, okay, the payment system, and then finally to the customer service, right? So there is an order once before the order is approved, right? The payment need to be secured, right? So this way, there are different approaches that can be done within Saga. Now look at the one more design partner, which is application event, which is also known as domain events, where it's kind of suited for domain-driven designing, where any particular entity and its all attribute, right, persisted, kind of considered as domain, and any change that is occurred, or creation of that particular domain is recorded, and then the final, what is the final domain object looks like, right? That has been published to the application which are they interested, right? That could be case, right, where the application are looking the latest information, right? They don't care about uh, kind of audit what has happened, but they always seek what is a data stage. So they always refer to the domain event of that particular entity, and based upon that they have their business rules or business scenarios in place. So that's where we can utilize the domain event. And it's also, like I said earlier, these design patterns are can be used with each other. We can use different design partner to solve one particular problem. It's not that they are one design pattern only be implemented, based upon there's a lot of time. The event sourcing partner sometimes coupled with the domain, and also Saga can be also coupled with domain. It's like kind of business problem, and what is the consumer of those events, what kind of event they are looking. They're just looking the change, or they are looking just the notification, they don't want to do anything, or they are looking the entire set of current state of an object. So that's pretty available for the overall solution of the applications. So looking again at all the design pattern together. So let me have a quick, before we go a little bit more detail into the analytics part, let me have just for a presentation wanted to show you Kafka. So what I have with me quickly, I have a Kafka image, and what I'm going to do is I'm just going to run that one, and I'm going to create one producer and a set of consumer, and see how quickly I can create the data streams within my system. Just me start. Yeah. Okay. So let me just create one quick producer. So I just have my all commands, so I don't have to type it. So, okay, let's say new. So this is what I've created, one producer quickly, and then I can create few consumers, and then I can show you what I'm going to do. Yeah, so I can point to this new topic. Okay, so my one producer is there. Okay, now let me do the same. Okay, and then I can do one more. So this is just to showcase a real example when there is one source of data, and within your organizations, there are different applications that need the same data for different purpose. One application need, let's say, to calculate the estimated time of delivery. One application which can tell the driver, okay, what are the routes are there. One application's just sitting just to have your resource planning, right? All of them need the same kind of, I would say, take the example of packages, right? They need all the details of packages what are scanned and different phases of their delivery, and each system is doing a different business scenario for, to at the end of the day that can be applied for this one. So let's say, okay, not here. Okay, here. Let's start with hello. So we see we got hello here. All the consumers get the same data. Okay. Hello world, the famous quote. Okay, welcome to my presentation. So as we are, it's kind of a data stream, as you can see, right? I'm just what I'm putting as my part of my producers. The same is went to each consumer that are interested into that particular data that we are looking, and that what we are utilizing Kafka as a kind of a stream platform, and that we are kind of each consumer will have its own unique copy of data they are looking for. Okay, wow, it's Friday. Okay, fine. So that's all got everything that is needed. So quickly jumping back into the presentation. So just kind of relating, right, all this what we have discussed so far, right, all the event-driven microservices, end of the day, right, they have to solve a particular business objective of an organization, right? And most of the organization in today's world, right, they are looking real-time analytics, right? So everybody asks, okay, what real-time analytics? Analytics is analytics. You have data, you run, you put your report, you slice and dice the data, and you have some context, how we can that data can be meaningful for the business, right? So just quoting something from Gartner, a leading research organizations, if what basically real-time analytics means, right? If you can put your logic and all the computations, and all the insight to make decision quickly, right? That's a keyword, right? You can make decisions, right? But how quickly, right? It's a fraction of seconds in the last minute, right? That's what's important in real time. If you have data for the last minute, right, that's considered more real time, right? So that's what is talk all about. If you just look at the analytics overall, right, real time analytics, and we'll start with more, I won't say traditional, but which is more, I would say, the very usual way of analytics has been always where we have data from our application. We have a lot of data warehouses, right? We have application, we have data lakes, data in cloud, data on-prem, right? That data is available, right? All from 5-year, 10-year, all historic data, right? That is also data is kind of data is gold, right? That's a statement, and it is in today's scenario, right? That data is being utilized, and I would say this is more traditional in terms of how this data is kind of extracted from different sources, but it's more in terms of more batch in process, right? And the famous ETL, right? Extract, transform, and load into a database, which can be utilized and queried by your analytics team, right? So this is basically, if I safely say, right, it's more of your kind of historic data, just loading into batches and giving to your team, which can run, okay, what are the trend, what are the predictions, right? How they can predict the future trends that come in place, right? That's awesome. That's good. And that is definitely working well, right? You're taking data all the way to your leadership and your business users, give them how they can plan and strategize, so they can have the right product or right planning in place, right? So that's one way. But with all due of real time, right, how we talked about, it's all data there, but now how about how we make decision real time, right? So that kind of approach of each kind of ETL has to just kind of take to the little bit of next level, where we say you have your real-time data, whether you have your IoT devices, your web platforms, or your cloud or your operational data, right? Whatever is currently happening right now, right? You just stream it to the operation database, whatever that is needed. And then you can build all your real-time applications, right? We have talked quite a few examples of your all real-time applications, right? They are uh, driven on based upon real data. The users is getting the real time feed of the car that are rental car the available just within 2 kilometers or within 5 minutes of distance, right? Or you are about to deliver a package in next 5 minutes, and then you see a user with garage or his door open, right, for you without failing on delivery, right? So that kind of things bring into how you stream your real-time data for real-time analytics, not just analytics, for all the applications, right? That kind of depend upon that the stream of data that they can have it. So that's what kind of I would say thought difference just between how we just build the analytics and dashboards from a kind of data warehouse rather than on the real streams. Now, important thing, right? We just talked about analytics and all the data, right? So let's talk a little bit about how this event-driven all what we started, right from this data, which is also, when we put a context, right, any event, it become more data relevant, right? So we know, right, we talked here and see machine learning all available, right? But it's what it feed on, right? It always feed on data, right? uh, they need data to learn, they need data to predict better, they need data to provide all the strategies. So most important factor we have to keep attention is, yes, they need data, but also the important question is, how do we get most of the data, right? Because data is not that it's just there in one system, it's distributed in today's distributed environment. Data is there in the whole ecosystem of the enterprise, right? Or could be outside the enterprise, need to get into the enterprise, right? So that's important. If you get the data right, then all the ducks on the road, then you have your data scientist or data engineer working on that data to build the machine learning or AI algorithm that you're looking for the strategic vision of your organizations. Let's just deep dive into a little bit more about how the overall event-driven approach can help in this journey, right? So the very first step, right, is data collection, right? You need to collect data, right? We have seen one way is you have your data warehouses, you have your all data going there, you get it from there, right? But now with real time, right, you can always listen to the stream of data, right, that is available. And definitely that is going to help all your engineers and data scientists or analysts, right, to understand that data and to create a kind of a new real-time data that can be used in further in the process. Once you have the data, you collected all your data touch points, right, from all your system, right? You have to get into an exploration path, right? You have to kind of add context to the data, right? If data in itself nothing, right, it needs some context or kind of relation, right, to have more qualitative data, right? End of the day, you don't need quantity, you need the quality of data, right? That is getting more important. Now, once you collected data, you have the data in place. Now, what you have to do is you have to have the preparation for the right data that you can continuously getting from your incoming events, right? And one way is like you have the mammoth size data, right? It will take a lot of time to slice and dice and have the right data prepared. But if you're getting the stream, right, which is, removing all the sensitive information, just anomalize it for your research and AI purpose only, right? So you can start with the data set, and then as and when you are incrementally getting the new set of data, right, you can keep feeding that data into your preparations. And last not the least, right, end of the day, whatever data effort that you have done, right, it need to go into a model, right, whatever model that you're working or that you are bringing on, right, that model, if it is more an event driven model, right, that can adapt to the change that is happening to the overall ecosystem. And nobody can understand, right, in today's time, right, how we are there with COVID, right? There is one wave comes, keep the organization change the overall framework of the applications, and then the wave goes, they need to open, and there are new rules and restriction from government, from the health emergencies that can come anytime, right? There is no prediction can work on that one. Something is emergency response, release tonight and is going to affect tomorrow, right? That becomes very, very critical, right? How quickly you can have your model, adapt to the change of data that is happening, or more and more real time, and you can just adapt your algorithm or your strategic vision as based upon the more event-driven data that you are collecting. With this said, I think I'm done. Is there more questions?
No questions from the audience at this time.
Okay. Well, thank you, everyone. I really appreciate.